So let's say our mean is about here. That's not red. There we go. Let's say our mean is here. Our median would be closer to the main data. So our mean gets pulled with whichever direction it's being skewed. So if I actually calculate the mean, in this example, that mean value would be bigger than the median's value because we go by these numbers down here. Has nothing to do with frequency. So if you look at where that arrow is pointing to, that's pointing to maybe 85. Maybe this value is about 85, and this one would be about 77. That means my mean would be bigger. My mean value, when I calculate it, would be a higher value. The farther right we go, the bigger the value. The further left we go, the lower the value. So anytime it's skewed right, our mean will always be bigger than our median. Anytime it's skewed left, our mean will be less than our median because it gets pulled to the left. Is that good? Okay. Other questions on the homework at all? We're good? Okay. Then today we are already having filled in notes. Let's find one that's blank, huh? There we go. Nope, that one's filled in too. How are they all filled in? Grant, what'd you do? Can I blame this on Grant? Give me one. All right, guys, today we're going to talk about measures of dispersion. Measures of dispersion, which are also called variability, are used to describe the spread of the data items in a data set. Two of the most common measures of dispersion are range and standard deviation. What dispersion is? It's asking you how far apart is your data. How far apart or consistent is your data? For instance, if I was a basketball player and I played 5 games and I made 10, 11, 9, 9, and 12 points. I'm pretty consistent around 10 points-ish, right? Versus, let's say I'm a basketball player now and my first game I scored 2 points, then I scored 20, then I scored 5, then I scored 10, then I score 3. It's kind of all over the place. So that would have a wide variance. It would have a big number representing that. The more consistent you are, the smaller these numbers are. So once again, the smaller your dispersion, the more consistent the numbers are. Our very first way to calculate measures of dispersion is range. Range is found when you take your highest value and you subtract away your lowest value. So range is going to equal max minus min. The good things about it is it's quick, but rough. It's a quick but rough calculation. What did I put for the exact words? I want this to be the same. It's a quick but rough estimate. Yeah, I did have estimate. So if I'm subtracting the max and the min, how many data points am I using? 2. I could have 100 data points and I'm reducing it to 2. It goes really quick, but it's not always that useful because it's a very rough estimate of how far apart the data is. If you think about me being a basketball player, if I shot a 0 and then a 20, a 21, a 19, and a 20, I'm pretty consistent, right? Except for that one game I had a 0. In range, it would say I have a huge inconsistency because it was 20 minus 0. So it's quick, but it's very, very rough and not always accurate of our data. But let's go ahead and do it here. So below shows the number of workers in millions for 5 countries with the largest labor force. So we have China, India, US, Indonesia, and Brazil. So we have 5 data points. We have 778, 472, 147, 106, and 82. I want you to calculate the mean, median, and the range. So you are calculating your mean, median, and range. That means we should have calculators out, we should have pencils down. We are calculating the mean, median, and range. All right, who's got my mean? Who's got the mean of this? Leanne. 317? How'd you come up with that?
I added all the original and divided by the numbers there were.
And how many were there?
5.
5 of them. So our n would be? N?
It would be
You just said it.
5.
5. Yeah, I didn't want to trick you. I just want us to remember that n is our number, so our n equals 5. Yes, so we would do all those added up and divided by 5. Sam?
Oh, I was going to say the median.
Okay, what's the median?
147.
147. How'd you come up with that?
Oh, it's in the middle of 5.
It's right in the middle of 5. Remember, our one way is if I only have 5, I'm just going to count. I'm just going to go his right smack dab in the middle. There's no better way to explain it. If it's a lot of data, we just go n plus 1 divided by 2. In this case, that'd be 6 divided by 2 would be our third number. Our third number is 147. All right, who's got our range? That's the brand new one. Aryan.
696.
696. How'd you come up with that?
I just subtracted the maximum from the minimum from the maximum.
Pretty hard, huh? So we just take that 778 and we subtract 82 from it, and that is our range. So our range is 696. That's a pretty big number. That's a pretty big difference between our top and our low end. So our range is actually 696 million, correct? All these should be in millions if you think about it. So really these are all in millions. All right, so that's quite a big difference between China and Brazil. Kind of what it shows for our dispersion. Bigger the number, the further apart our data is, the more spread apart our data is. Now, range is good, and it works for this one. We agree that our data is all spread apart. Yeah, nailed it, but it's not always going to. So sometimes we need a more specific way of describing our dispersion or how far apart our data is. And that's when we start introducing standard deviation. What standard deviation is going to be a number that represents how far away each data item is from the mean. So it's found by determining how much each data item differs from the mean. So the good thing about this, okay. It's much more accurate. It's much more accurate than the range. So it's more accurate. And why is it more accurate? Well, it uses all of the data. So it's more accurate because it uses all of the data. Range uses 2 points. Your standard deviation will use every single point that was given to you, and it's going to compare it to the mean. All right, so we're comparing all of our points to the mean. So it makes sense that our first step is actually comparing each point to the mean. Our first step is to take all of these numbers, 778, 472, 147, 106, 108, and compare it to the mean. We're going to take our data and subtract the mean away from it. That will give us our distance from the mean. Well, I think it was Leanne. You already came up with the mean for us, right? So our mean is at 317. So we're going to start with, remember, X bar is your mean. Know that symbol, just like N is your number of your data items. X bar is your mean. Our mean is 371. I can't believe I already forgot it. Yeah, no, it's 317. Transposition in your head. Now what we're going to do is we're going to take each one of those data items and subtract 317 away from it. So we're going to calculate 778 minus 317. We're going to do 472, and we're going to subtract 317 away from that. Then we're going to take 147. We're going to subtract 317 away from that. We're going to do 106, subtract 317 away from that. And finally, we're going to have 82, and we're going to subtract 317 away from that. So let's go ahead and put those in. You should have negatives out. So our first step is taking each of our data items and subtracting the mean from each one. Negative items do apply. So I'll go ahead and put my numbers up there while you guys are working. Oh, that should actually be negative 170. right, so the numbers I ended up getting were 461, 155, negative 170, negative 211, negative 235. Add all those numbers up. Add all those numbers up and tell me what you get. What do you get when you add all of those numbers up? Yeah.
500.
Ooh, we shouldn't get 500.
0.
Brendan, we get 0 out. You should get 0 out because we're looking at the distance from the mean. Your mean is supposed to be smack dab in the middle of your data. So you should have the same amount above as you do below. Well, that's a problem because I kind of want to get the average of these numbers. That's what I was saying. I want the average distance from the mean. So I can't just add those up. So what we are going to do, and pay attention to this, we are going to square each of these numbers, which will make it positive. And what should be clicking in your back of your head is, why don't I just use absolute value to make them all positive? Wouldn't that work, make them all positive? Would taking the absolute value make everything positive? Yes. So it'd be a good common sense thing to take the absolute value. Let me tell you why we square them. We square them to give more weight to bigger and smaller numbers. When I'm calculating variation, I want to take in account outliers. I want to take into account outliers. So I want to give more power to those outliers, saying, hey, this brand has a big problem with outliers. So when I square them, it gives more power to those bigger and smaller numbers. So if you have outliers, it gives them a little more power in the problem to say, hey, there's outliers here. There's a problem with some of these data items. All right, so we square them to give more power to the bigger and smaller numbers. That's why we don't just take the absolute value. So what we are going to do is we're going to square all of those numbers we just got up there. So we're going to do 461. We're going to square them. We're going to square 155. We are going to square negative 170. We are going to square negative 211. We are going to square negative 235. And then after you do all that, you're going to add them all up, and you're going to put that sum right here. So you're going to square each of these, and then you're going to add them all up. Try to beat me. All right, so when I squared them all, I got 212,521. 155 squared is 24,025. Negative 170 squared is 28,900. Negative 211 squared is 44,521. Negative 235 squared is 55,225. And when I added all of those values up, you should have came up with 365,192. You need to be quick on your calculator because the longer you take to do these things, the less time you have to use to think and work on other problems. So get used to using your calculator quickly. All right, so now I'm sitting there with 365,192. That's what happened when I came up with our distance from the mean. I squared them and added them together. What we are going to do next is we're going to average that number. We are going to average that number by dividing how many total data points we started with, and we started with 5 of them. So I'm going to go to my next slide. I'm going to say, well, my N was 5. We had 5 countries. I'm going to go ahead and take that number, and I'm going to divide it by 5. And I got out about 73,038.4. Now pay attention to that number because that number has a specific name. When you take your sum of squares and divide by your n, that is called your variance. You have to know that word, variance, because there are going to be times where I don't ask for the standard deviation, I just ask for the variance. One last time to say how important it is you need to know this word. You need to know the word variance. In fact, variance is the step right before you get your standard deviation, because our next step is getting our standard deviation. So let's go ahead and do our standard deviation. That's spell it right. The symbol for standard deviation is just a lowercase sigma, which is like a circle with a tail coming off the top. Know that symbol. So that's going to equal the square root of your variance. That'd be that 365,192 divided by 5. We can either plug this number in, or we can plug this number in. We'll get a more exact answer if I plug this one in because we rounded this one. We're just taking the square root of our variance, which is going to result in about 270.3. So our standard deviation is 270.3. Yes?
So we can't do 73,038.4 because that's the exact answer.
Like I just said, you can use either one of them. But if you use the fraction, you get a more exact answer because we rounded this one.
Oh, really?
I would almost always just plug this in.
Okay.
I would almost just use the fraction just to get it more exact. And we aren't going to we're not going to be doing what we do with square roots. We're just going to plug it in our calculator. All right, don't worry about simplifying it. We're just going to plug those in your calculator and you get those values. Okay? Now the big thing is here, the bigger the number, the more variance it has. In other words, the least consistent it is. So 270.3, that's 270.3 million. That means you're varying about 270.3 in either direction of the mean. That's a pretty big number. That's a pretty big number, and it reflects our data. Our data is kind of all over the place. It goes from 778 to 82, 106, 147, 472. So the bigger this number is, the more deviation it has, and the less consistent your data is. All right, on the backhand side, this is what we just did, step by step. I'm also going to put, by standard deviation, I'll put a little symbol by it, because like I said, you need to know that symbol. That is our symbol for standard deviation. I also put to the right of it, the computation of standard deviation can be organized using a table with 3 columns. It is the best way to keep all of your stuff organized. If you are not organized when you're doing a standard deviation, it's kind of like the test we just took. If I can't figure out what you're doing and you don't have it correct, you just lose more points. So the most way you're going to get points is to organize stuff as best as possible. And using a table will keep stuff really organized. So we're going to go ahead and do that right below. We are given 2 batteries. We're given brand A and brand B, and we're given a whole bunch of times. So I took 7 batteries from each brand, and I tested them how long they lasted. Let's come up with the mean of both of them. So we're going to find the mean of brand A, and we're going to find the mean of brand B. Let's work on what I'm asking you to work on. The mean of each of them. Yeah, of both of them. If you're going to work ahead, make sure you at least stay with the class. Are you working on the mean of it? You should all be doing it. Don't wait for someone to give an answer. Are you working on your mean? I don't see you typing anything in. Once again, I shouldn't have to come over to you to directly tell you to do it again.
What should be parents? Oh, yeah.
Well, just have an answer at the very least, yeah. But we're going to put them right by where it asks for it. All right, what did we get for a mean for brand A? All right, 99. What did we get for our mean of brand B? We got 100. All right, cool. Well, let's stop there for a second. So we have brand A is 99 and brand B is 100. Let's go down to that question that says which brand of battery lasts longer on average? Which brand of battery lasts longer on average? Hamza?
B.
Brand B. Perfect. We're going to hold off on the next question because this question leads us to say that brand B is the one I want to buy because on average it lasts longer. But we're going to hold on to that question. We're going to first fill out these columns. I'll fill out this one with you, and you're going to do this one all by yourself. So this is how these columns work. See this data? It's going to be organized from smallest to biggest in this case, but it doesn't have to be. All right, I could put 87, 95, 103, 93. It doesn't have to be in magnitude because we're not finding the median. So you just write the data in whatever order it comes in. In this case, it does come in order as 87, 93, 95, 103, 104, 104, and 107. But if I changed any of these, it wouldn't mess up the problem. All right, so order doesn't matter here as long as all your data is there. Then we're going to do data minus mean. Well, our first data piece is 87, so we'll do 87 minus 99, which equals a negative 12. Then we'll do 93 minus 99, which equals a negative 6. 95 minus 99 is negative 4. 103 minus 99 is a positive 4. 104 minus 99 is 5. Then we'll have 5. And then we're finally going to have 8. Our next step would be to square all those values. So our first value was negative 12. So I'll go negative 12 squared. Well, that equals 144. Negative 6 squared equals a positive 36. Negative 4 squared is 16. 4 squared is 16. 5 squared is 25. 25. And finally, 8 squared is 64. So once again, our order was data, subtract the mean, square it. Now we're going to add them all together. When you add them all together, you should come up with 326. And now I'm going to calculate our variance. Our variance is our sum divided by our n. Our n in this case would be 7. There were 7 batteries. So our variance is sum divided by n, so that'd be 326 divided by 7, which comes out to about 46.6. That's our variance. Our standard deviation, on the other hand, will equal the square root of 326 divided by 7, which is going to be about 6.8. And for this case, I'm going to put, that's about 6.8 hours, because we can still use the units that were given to us. It's about 6.8 hours. Now what I want you to do is I want you to calculate the standard deviation of brand B. Calculate the standard deviation of brand B. Don't wait till I start walking around. Start working on it now. All right, for the sake of time, let's just keep rolling. Here's the values I got. I got negative 27, negative 24, negative 8, negative 6, 13, 20, 32. When I squared all those, I got 729, 576, 64, 36, 169, 400, 1024, which resulted in, 2,998. Variance is 298 divided by how many batteries we had. We had 7. So it's about 428.3. Our standard deviation is the square root of our variance, which should come out to about 20.7 hours. Does anyone disagree on any of those numbers I came up with? Okay, let's revisit that question that said, which brand of battery should you buy? So at first I said maybe you'd buy brand, yeah, Hamza.
I just have a question on this. What does variance give?
Variance is the number before you take the square root of it. So some people use variance in place of standard deviation.
Okay. Which one, what is the difference?
What is the difference? One is the square root, and it makes more sense in the data. Because one is 20.7 hours, one is 428. It's before this, but you can use that if it's a really big number. It's also going to be a big.
Okay. Does it tell us anything about the data?
Like I said, the bigger variance is, the bigger standard deviation is. So we can look at variance. If it's a really big number, our spread's also going to be very big.
Okay.
All right, so we can use it as a quick approximate. If that's a really big number, I don't know how the standard deviation is, but I know it's going to be big.
Okay.
All right, so let's go back to that question. The question was, which brand of battery would you prefer to buy? Which brand of battery would you prefer to buy? Honestly. Yeah.
It's more reliable.
It's more reliable. And are their means that far apart? They're 1 hour apart. But if we look at brand A has kind of a plus or minus of 6.8 hours. I'm going to get 99 hours plus or minus 6.8. Where brand B is, I'll get 100 hours on average plus or minus 20. So A, the smaller the number is, the more consistent it is. When I buy a battery, I probably want a consistent battery. I don't want to roll the die and be like, well, there's a good chance I might get something that lasts a long time, but I might also get one that lasts very short. And you can see that in the spread. I might get 132 hours, or I might get 73 hours. It's not very consistent. So brand A would probably be a better purchase because it's a lot more consistent. Isabel, did you still have something?
I was just wondering what standard deviation means. That's just like how far from the average is.
Yes, that's exactly what it means. It means our data is about 6.8 away from the mean on average. Yep, that's all I'm saying. So the bigger the number, the further our data is spread apart. The smaller the number, the closer our data is together. So this is 6.8. So if I look up there, we have a spread from 87 to 107. They're pretty consistent between the amounts. Where brand B went from 73 to 132 and it's pretty, spread apart. Okay? So it's basically how spread apart is our data. All right, any other questions on what we covered today? Okay, we should have all received our test back except for JK. I got to figure out where I stuck that guy. But test corrections are due in 1 week, so that'd be next Thursday. Test corrections are due. That is only if you have less than 80%. All right, if you have less than an 80%, you can do test corrections. All right, otherwise, that's all I got for you. The rest of the time can be for you.